Okay, let's talk about antacids because this came up on the discussion board, and I just want to make sure everyone has at least a good visual description in their mind of what's the difference between, when we talk about antacids, the difference between PPIs and H2 blockers. So let's see if we could bring up the marker here to show you this. All right, so we can see right here is the parietal cell. And one of the things that's going to make this parietal cell, as you can see here, right, here's on the right-hand side another parietal cell, and it's pushing out hydrochloric acid. But how is it going to do that? So let's say if we look at this one on the left-hand side, here's a receptor on the cell, and it's waiting for, we're going to call this H2. This is type 2 histamine. So type 2 histamine hits this receptor, and the parietal cell can now start to push hydrogens into the stomach. Remember, hydrogens are an H plus. We could see that here. And we know that these H pluses are what we call protons. Okay, so now this makes a little bit more sense to us in terms of knowing, are we going to be using a PPI, right, a proton pump inhibitor? And if we're going to be using a proton pump inhibitor, it's going to be blocking the, let's use this. It is going to be blocking this portion here. But if we're using a histamine blocker, we're blocking this before the parietal cell, all right? So both, whether we're using and blocking the H2 or we're blocking the protons, both of those, the end result is going to be increasing pH, and which is potential or percent hydrogen. All right. So when we increase pH, if we look at the scale from 0 to 14, and we know that right in the center there is 7. 7 we know is neutral, but the hydrochloric acid pH is right around here, which is about a 2.3. 2.3 pH. Let's make that a better 2. All right. So when we start to block the protons, and this isn't happening, the pH starts to move up to a more alkaline environment. And what'll happen is now bacterial overgrowth. When you don't have that acidic pH, right, if we don't have this on top, then we can't take this inactive pepsinogen and make it into this active pepsin, right? And then when you don't have pepsin, then you can't break down your proteins. You can't break down your proteins, you can't make neurotransmitters, can't make bones, can't make muscles, right? Lot of problems arise. And then also keep in mind that this parietal cell is also producing intrinsic factor. And we know that intrinsic factor is needed to bind with B12. Okay, super important. But that can only happen in an acidic environment. So once you start raising the pH, this doesn't happen, and you can't absorb B12, and now you can get these methylation issues. And we also need an acidic environment for calcium to be absorbed, for iron to be absorbed, magnesium, right? So super important stuff.